Hello and welcome to this video on forming the composite function. So in this video I'll start off with defining what the composite function is, what a composite function is, and then how to evaluate such a function on the next page. And then after that, several examples where I'm forming a composite function given two functions, and then evaluating those functions, those composite functions. Okay? So on the first page, I'm going to discuss the definition of a composite function. All right, I've already written this out. All right, so composite functions. Given two functions, say f of x and g, right? F of x and g of x. So given two functions f and g, the composite function, really a composite function, denoted by f, then this little o, right? Notice this is an open point. This is an open circle. Don't fill it in if you're writing this, because if you fill it in, it'll be implied to be multiplication. It'll be f dot g. When you see this f and then a little o and then another function afterwards, and again, these don't have to be f and g. This could be g of f or g composed with f, or h composed with k. The names of the functions don't really matter. But when you see this symbol, this little o symbol between two function names, that stands for function composition, or composed with. So I would read this as f composed with g, f composed with g. All right, and the way it's defined is, this basically you're taking two functions and creating a new function. Right, so this fog here, f composed with g, this is the name of a new function, and you could call this new function h or something. But usually it's kept this way. This is the name of a function. So we have this function f composed with g of x, and over here is how this function would get evaluated, right? So f composed with g of x at input x is equal to the value of f at the value of g at the value of x, right? Or f of g of x. That little symbol, f, and then in parentheses I have g of x. That f with g of x in parentheses is read f of g of x. And this gives me an idea as how are these composite functions evaluated. All right, and really all that's going on here is substitution. So when you see this, you're taking function g, you're just substituting function g into function f. Yeah, it's just so function composition is really just a bunch of substitution. All right, and I've defined on the next page, I'm going to show you how would we go about taking a new function like this and evaluating it. All right, so evaluating composite functions. So to evaluate a function that looks like this, that's composed of two other functions, f composed with g of x, or f of g of x, you take the input x, right? Remember the number in parentheses after the name of the function is the input. All right, so this number here, whatever number that is the input. And then f of g, right, the name of the function represents the output. This whole thing, f of g of x, represents the output. So I take the input x and I put it into the first function that I see next to x, right? Plug it into g. I'm going to take this number x and plug it into g, right? So I plug it into g, evaluate g at x, so that gives me this g of x inside, right? G of x, g of x. And then I take that number g of x, whatever that number is, and then the number g of x gets, as I mentioned on the previous page, gets input into f of x, right? It's in the parentheses after the name of this function f. So x goes into g, and then I find g of x, and then I take that output g of x and make that the input of the next function over f, and then find f of g of x, right? So it's really just, you can say it's going from right to left or from inside out, however you want to think about that. All right, so there are a lot of letters in the last couple pages, I know. So let's get to some actual examples. All right, so I will bring these back. Maybe not. I'll just describe what I'm doing. All right, so my first example where I'm asked to, compose two functions, right? I see this O symbol for function composition. All right, suppose we're given two functions, right? Suppose that f of x, function f, takes the input x and you calculate the output this way. F of x equals 4 times the input minus 3. And g of x, another function g, which takes the input, and then squares it and then adds 1, right? X squared plus 1 is the output for this function g. I'm asked to find the value of the following. So what's the value of this expression here? What's f composed with g when the input is 2? Or, as I was saying in the previous pages, we can write this another way. We can say this is also what's f of g of 2, right, with all the parentheses. All right, so remember the steps I wrote. I'm going to write them, I'll write them, in relation to this particular example here. So the first thing, take this number 2. I'm going to input 2 into the function g, right? I'm going to find g of 2 into g. So then the next part is, find g of 2, right? Evaluate. All right, well, what is g of 2? Well, remember what you do when you're finding g at 2, the value of g at 2? Just go through the rule for g and replace all the x's with 2, right? So g of 2 would be 2 squared plus 1, which is 5, right? There's g of 2. That's an important number right there, 5. Then I take that number, right? So what I have here, f composed of g at 2 is equivalent to f of g of 2, which will be equivalent to f of, and we just saw that g of 2 here, right? This g of 2 is the number 5. Okay, and then all we're doing next is finding f of 5. Right? I'm going to be inputting this 5 number, this g of 2. I'm going to input 5 into the only function name left, into f. And find or evaluate f of 5. All right, what is f of 5? Well, you go to function f and replace all the inputs, all the x's with 5. So what is f of 5 would be 4 times 5 minus 3. That's 20 minus 3, which is 17. Right? And that's the final result. So in other words, at the end here, I would just simply say the value of this f composed with g function, this composite function, f composed with g, the value of f composed with g, when the input is 2, the output is 17. Great. All right, so keeping these same functions up, right, let's see what happens when, now I've had f composed with g so far written out, but it doesn't matter like what the names of the function are. I have f and g here. You could have f composed with g, or you could have g composed with f. But you're going to see in a second that the order you put them in does matter. All right, you're going to get different values for different orders of composition. So I see that f composed with g at 2 is 17. The second part, let's find the value of this new composite function called g composed with f. Notice the different order. All right, and I'll write that note after we're done with this example. You're going to see that the order does indeed matter. Alright, so as before, another way I can write g composed with f at 2 is g of f of 2. Alright, so I'm not going to write out the steps this time. I'm just going to tell you the order I'm doing things in. Right? What we're going to be doing is finding, the number 2 here. That's the input. I'm going to plug it into f first, right? So we're finding f of 2. Alright, so I'll do that off to the side. What is f of 2? Alright, so I go to my function called f and replace all the inputs with 2 to get the output. F of 2 would be 4 times 2 minus 3. And 4 times 2 is 8, minus 3 is 5. So again, very, very important number there. That's what f of 2 is, the value of f at 2 is. Alright, so g composed with f at 2 is equal to, g of f of 2, but f of 2 is 5. So this is equal to g at 5, or g of 5. Okay, and now what I'm being told to do here is put 5 into the next function, the only function named left. Put 5 into g. Right, and what is g of 5, right? The g of f of 2. Go through the rule for g, right, the function g, and replace all the inputs with 5. So g of 5 would be 5 squared plus 1. Well, 5 squared is 25, plus 1 is 26. So I'm getting 26 at the very end, right? So we would say here that the value of g composed with f, right, this new composite function, g composed with f, the value of this function when the input is 2, right, the output is, that value is 26. Now look at this. Compare this to part A. Right? In part A, I did f composed with g at 2. In part B, I did g composed with f at 2. Notice in both of these parts, the input was the same, but the outputs were different, right? The value of f composed with g at 2 is 17. But just switch the order. Just switch the order. The value of g composed with f at 2 is 26, which is not 17. Alright, so I'm going to put up a very important note here relating to the order in which you compose two functions, the order in which you form a composite function. Alright, so note that f composed with g at some input is not always equal to g composed with f at the same input, right? And notice these are both x here. So f composed with g at x is not always the same as g composed with f at x. This is for some functions f and g. Okay, I'll say some. Alright, because there are some cases, alright, there are some cases where they are going to be equal, but we're not going to come across those just yet. Alright, but in the beginning, usually when you first start off learning about composite functions, they like to throw examples like this at you, like I just did with part A and B here, where if I just simply switch the order in which the composition happens, the composite function is formed, I get different outputs. Right? They're not equal. The order matters. Right? The order in which the functions come in matters. Right? Okay. All right. So now let's sticking with the same example. All right. The same two functions. Got one last example here. So far I've seen f composed with g, g composed with f. They don't have to be different letters. Again, this could be any names of any functions you're looking at that get composed. So here I'm asked to find the value of f composed with f composed with itself. When the input is -3, what's the value? What's the output? All right, so as before, all right, another way this can be written is f of, right, f of f of -3. All right, so as with the first couple examples, the first thing I'm going to find is f of -3, right? This expression inside the parentheses here, where I'm taking the input of -3 and putting it into f first. So what is the value of f at input -3? All right, so I go to the function called f, right? Pay attention. This one's f, and what's the output when the input is -3? F of -3 would be 4 times -3 minus 3. All right, and 4 times -3 is -12, minus 3 is -15. Again, very important, that one. Let's back up here. So the value of f composed with f at -3, or the value of f of -3, is the same as the value of f at -15. All right, that's this value of f of -3 inside here. All right. Okay, and now we're just taking -15 and plugging that in to f again, right? So again, I go back to the function called f, but this time I'm plugging in -15 and not -3. All right, so function f, that's this one, at -15, right? So just replacing all the x's with -15. That'd be 4 times -15, then minus 3. Well, 4 times -15 would be -60, minus 3 would be -63. Okay, so this value in the very end would be -63. Wonderful, right? And again, I could write this in the very end like this, right? The value of this composite function, f composed with f, the value of this composite function at an input of -3 is -63. That's how I would write the final result there. Okay. Now, so I've done, I could have done g composed with g, and you'll see later, I'm not going to get into any examples of this, but you can compose more than 2 functions. I could ask for what's f composed with g composed with f, and again, it's just one extra step. You just do the same steps over and over again. So I would plug the input into the first function, take that output, plug it into the second function, then take that output, plug it into the third function, right? You can have a composition go as long as you want, all right? But we're going to stick to just this for this first video here, stick to composing 2 functions, all right? Okay. Well, every single one of these examples, right, A, B, and C here, had an input that was a number. All right, but the input doesn't have to be a number. All right, the input could just represent a number, right? The input could be a variable or an entirely different expression that just represents a number. All right, so that's what my last examples are like. So my last examples involve these 2 functions. All right. So suppose that function f and g again, I have f of x equals x squared minus 3 times x plus 1. And this function g of x, is 3 times x plus 2. Okay. Find this. All right. So what's this composite function f composed with g at just the input x, right? X just represents any old number. All right. So I do the same stuff I did before, right? I'm going to rewrite it in that other way it can look, right? F composed with g at x is equivalent to saying f of g of x, like this. And like the examples before, I'm going to take this number x, right? This represents a number, put it into g, and find g of x, right? Well, we already know what that is, right? G of x, the value of g at any x is 3 times that x plus 2. Okay, and that's it. That's as simple as I can get. I don't know what x is, right? So this will be equal to f at, the value of f at, and then g of x, as we just said, was 3 times x plus 2. Right? All right, and then what I'm doing is taking 3x plus 2, right? 3x plus 2 is now the input for f. So it's a little funky, right? Because it's not just a number, it's a whole expression, but it represents a number, right? Every expression represents a number. And I'm plugging this expression into f. So now I'm finding what's f of 3x plus 2. So I go to the function f, and everywhere there's the input, right? Everywhere there's an x, I'm going to now replace that x with this quantity 3x plus 2. So f of 3x plus 2 would be, not x squared, but the quantity 3x plus 2 squared. And then minus 3, times not x, but the quantity 3x plus 2. Right, just going through and replacing all the inputs, all the x's with g of x, with 3x plus 2, and then plus 1. So you see what I meant earlier about how this function composition is really substituting one function into another? See how I took g of x and just substituted it for x in the function f? Right. And then of course I would like to simplify this. Now 3x plus 2 squared. Remember, this is not 9x squared plus 4. Do not distribute powers. Remember, this is 3x plus 2 times 3x plus 2 again. You would FOIL and get 9x squared plus 12x, then plus 4. All right, that's the 3x plus 2 squared, these guys. Then here I'm distributing the negative 3 to get minus 9x, and then minus 6, and then you have the plus 1 term at the end. And combining like terms, I have 9x squared, there's the 12x, and the negative 9x, making positive 3x. And then the positive 4, the negative 6 would make negative 2, and then plus 1 would make negative 1. Okay, so the value of this function, this composite function, f composed with g, at any input x, would be 9 times that x squared plus 3 times that x, and then minus 1. All right, great. And you can try it out. All right, we're actually going to see later. I'll test this. All right, we'll see. We'll do a little check on this to see if this is actually correct. All right, well that was f composed with g at any input x. What happens when I switch the order? Right? Remember earlier I said in a lot of cases, right, not all, right, there are going to be some cases where the order doesn't matter, but in a lot of cases, when you switch the order of the functions you're composing, it changes the output completely. All right, and we'll probably see that happening here as well. All right, so same two functions. All right, same two functions, this f and this g. But now in part B, I'm asked to find, what's g, the composite function g composed with f at, the value of it at the input x, right? So, and again, I can write this another way as g of f of x, like this. All right, so just like all the other examples, right? The first thing I'm doing, I'm taking this number x, plugging it into f first, right? So what's g of f of x? All right, so first I want to find f of x. Right? Now f of x, we know, right? That's this x squared minus 3x plus 1. That's the output when I plug x into f. So that's going to go in the parentheses here after the name of g. So we have g of, and then f of x is this x squared minus 3x plus 1. All right, and then I'm taking that number, right? Again, it looks crazy because it's not a single number, right? But it is an expression, and every expression represents a number. So I take this number, this x squared minus 3x plus 1, and I'm plugging that into g. So I go to the rule for g and replace all the x's with this quantity x squared minus 3x plus 1. I'll do that off to the side here. So I'm finding g of x squared minus 3x plus 1. Again, just go to the rule for g, the function g, and everywhere there's an x, I am now going to replace it with x squared minus 3x plus 1. Okay, so g of x squared minus 3x plus 1 would be equal to 3 times not x, but 3 times the quantity x squared minus 3x plus 1. And then you have plus 2 after that. So again, you see what I'm saying, where when you do function composition, it's just taking that first function and substituting the rule into the second function, right? I took the rule for f and replaced all the x's in g with that rule. I substituted it into the rule for g. And then of course simplify, right? I have a 3 to distribute here. So we have 3x squared, then minus 9x, then plus 3, and then the plus 2 after. And those are the only two like terms. They make plus 5. So I have 3x squared minus 9x, then plus 5. Great. And that's the final result. Right? I'm only composing these two functions. So the value of g of f, or the value of g composed with f, at any input x is going to be 3 times that x squared minus 9 times that x, then plus 5. All right. And notice again how the order mattered. All right, look back at part A again. Look at how f composed with g at input x gave me this polynomial output, this output, 9x squared plus 3x minus 1. But just switching the order, g composed with f at the same input has a different output, right? This is not the same output, not the same expression. 3x squared minus 9x plus 5 is not the same as 9x squared plus 3x minus 1. Right. Again, there are some cases where they will be the same, but so far all we've seen are some cases where they're not the same, right? So the order in which you compose actually means something. All right. Okay. Now for my last example, I mentioned earlier I was going to test out this first one, right? And you can do the same test, a similar kind of test for part B if you wish. All right, so the last example, part C, right? Again, the same two functions, okay, same two functions. And I'll leave part A, the result from part A up here, right? So I'm asked to find, like I did in my first examples on this video, what's the value of the function f composed with g, this composite function, when the input is -2, right? F composed with g at -2. Now, I can do it two ways. All right, so remember I could do this where I do it the way I did it on my first examples. I rewrite this as f of g of -2, right? And what we're doing is we plug -2 into g, right? So we're finding g at -2 first. So I go up to the rule for g, right? G at -2 would be 3 times -2 plus 2. And that's -4, right? -6 plus 2, -4. All right, so then this becomes f of -4, right? G of -2 is -4. And then all we're finding now is f of -4. Right. Separate this. And then what is f at -4? Go to the rule for f, replace all the x's with -4. That'd be -4 squared minus 3 times -4, and then plus 1. So that's 16 plus 12, right? Negative times negative, and then plus 1. That's 28 plus 1, that's 29. All right, so the value, that's the final answer here. The value of f composed with g at -2 is 29. Now that's one way you could do it, right? This is the way I did earlier in the video. But another way I could do it is, I already have a rule for this composite function, this function called f composed with g, or f of g. I have it here. All right, so keep the 29 in mind. I'll bring that back. All right, let me pull this off actually and pull this up. So this was the composite function we found earlier, right? F composed with g at x is 9x squared plus 3x minus 1. You can use that rule, right? So, or I'm finding, remember it was f composed with g with the input of -2. Just go to the rule for this, right? Just like any other rule, right? I go to what's the rule for the outputs of f composed with g? That was this, 9 times x squared plus 3x minus 1, where the x is now -2. I'm just going through that rule and replacing all the inputs with -2. So f composed with g, or f of g at -2, is 9 times -2 squared plus 3 times -2 minus 1. Now hopefully, if I did everything correctly, this will give me 29 like I found earlier, right? It better be if I did everything right. So this is what, 9 times 4, right? Remember, -2 squared is 4. Okay, and sorry about the phone ring there. But yeah, -2 squared is 4. And then, positive 3 times -2 is -6, and then minus 1, and, this is 36, 9 times 4, then minus 6, minus 1. That's 30 minus 1, 29, which is what I was hoping for, right? That's the exact same value I found earlier, when I did it the first way we did it earlier in the video. Got 29 that way as well. So this rule seems to be a good rule, right? I seem to have done my work properly. Okay, so again, I hope that all made sense. I hope being able to form a composite function, just basically substituting one function for into another. Hopefully that seems easy enough to do, and also evaluating a composite function where you take your input, put it into the first function, find that output, then take that output, put that into the second function, and so on. If for some reason there was a composite of 3 functions or 4 functions, you should still be able to do that if you follow the same steps, same order, same rule that we were following here with 2 functions. Okay, and as I like to say at the end of these videos, do the best you can to learn the material on your own before you go looking for help. I found over the years that people that take the time and the effort to learn something on their own tend to remember that material better and remember it for longer, and are more proud of themselves, have more confidence in their abilities, which is always a good thing. So of course, read the material, right? Read through the author's examples. Perhaps even try to work out the solutions to an author's example before you see how the author did it, and then compare your work with the author's and see if you can learn from some mistakes there. Obviously, do tons of exercises, practice problems. Practice makes progress. It's the only way to get better at anything. And check the solutions to those if they're made available to you, so you can track your progress, see how you're doing. And don't just give up on a problem after 1 or 2 attempts. Very often in mathematics, there are several approaches. Like even in this last example, you saw how I found f composed with g at -2. I found it in 2 different ways. Very often in mathematics, there are several different approaches that'll work for any particular problem. So if after several attempts at a problem or several problems, you're still struggling, still having trouble, I would actually suggest to you to go back and read the material again, perhaps even a 3rd time, more slowly, more deliberately. Take good notes, organize those notes later too, so that they're easier for you to read and understand. Because if you've been working on problems as you should, there's a good chance you have a better idea as to what the author wants from you, what the author expects from you, what the author finds important about that material. So when you go back and read again, you pick up a lot more. You know better what to look out for, what is important. Perhaps even some things will pop out at you that didn't pop out the first time you read through, and it'll make working on the problems that much easier. But if after that, if after several read-throughs of the material and several approaches at the problems, if you're still struggling, still having trouble, if after all that, if you've gone through the effort and put forth the effort and exhausted all your physical and mental capabilities to help yourself, then it's not a sign of weakness to ask for help. Okay? Just don't do it immediately, though. Don't give up so easily. But that's what other people are there for, to help you when you're struggling. Again, if you've put in the work ahead of time, too. I mean, people can't help you if you haven't tried to help yourself first. So ask a teacher, a tutor, a friend, someone in your class who you know knows the material well and is willing to help. Look for supplemental materials online. There's tons of that out there. Look for videos online, videos like this one, or plenty of other ones out there that are better than this one. I assure you they're out there, and they're easy to find. But just stay at it, keep at it. Stay persistent. Keep practicing. Don't give up. And above all, and I think this is the hardest thing for most people, stay positive, please. Have belief in yourself. Believe in your abilities. Believe that you can learn it. Believe that you can make it. Even in those times of struggle and failure and frustration and when you're making mistakes, just believe that you can push through and do it, because it's in those times of failure, those times when you're struggling, that you have the opportunities to learn the most, and also learn the most deeply. Because if you can persevere, if you can persist, if you can push through your frustrations and make it to the point where you learn how to fix your mistakes, then you'll remember that material far better and far longer than someone who just got it right the first time and breezed through and never gave it a second thought again. Right? You'll remember it better because there was emotion tied to it. There was struggle. There was frustration. There were tears. There was emotion tied to that. And when there's emotion tied to information, that's when memories happen. Right? You will form a strong bond with that material if you push through and don't give up and actually make it to the point where you learn how to fix your mistakes. So please keep at it. Stay persistent. Keep practicing. Stay positive and don't give up. And I just know you'll get it. And thank you very much for watching.